Hi, everyone, and thank you so much for coming. My name is Kolani. Most people call me Mr. X, and today we are doing a grade 11 topic. The title for it is Exponents and Surds, and it's a free class. Welcome, everyone. Normally, I don't do free classes. That's why you can see on the poster there, slashed my prizes there. But I am doing this because I love you guys and I want the best for you. But then something big is going to happen in about 2 weeks' time or so, whereby I will be doing the maths and physical science classes at a very discounted price online on Zoom. Classes start on the week of the 26th of February. In 2023, this was costing 100 rands for a 2-hour lesson. In 2024, believe it or not, it's going to be 50 rand for a 2-hour lesson, but the condition is that you must pay for a minimum of 2 lessons at a particular time. So therefore, we're going to be starting on the week of the 26th. In each month, I will do 4 lessons maths, 4 lessons physical sciences, 2 hours a day, and I'll give you all the details. Please join my WhatsApp groups. I'll also put my number here, or I'll say it out, 073 974 84 98. All right, perfect. On our last part, we did do a bit of some rules of exponents, and I'm just going to start on this exercise. The first part will be exponents, then the next part will be surds. There we go. We will start here for our particular lesson. I'll do a couple of questions with you. You let me know where you don't understand, but let's get ready to play around with all of this. The question says, and I'm going to put my video off in the meantime, and I will just be hearing me and also seeing what I'm writing. So it's important that when you're doing maths to understand the question, do not rush when reading the question. You can't answer what you do not understand. And the question says, simplify the following without using a calculator. Simplify the following without using a calculator. I'll pick a couple of questions so that we can have a bit of some fun here. Let me just start quickly with question number 4. I'll start from there on. It says to me, 2x cubed over 8y to the power negative 4, all of this to the power of 3. This reminds me of a rule in exponents whereby we are saying to ourselves in that particular rule of exponents, it says to me a over b to the power of m. And if I do that, it means the m is powering a while at the same time is powering b. So that becomes a to the power of m over b to the power of m. So by extension, it means this 3 that you see is powering the top guy as well as the bottom guy. Very important to understand that. That 3 that you see there is powering top and bottom as well. But at the same time, I just want you to remember this rule as well. If I say to you a to the power of m to the power of n, what it means is that it's a to the power of mn. So it's a to the power of m multiplied by n. Let's do this question here. So we've got 2x cubed over 8y to the power negative 4. Everything is cubed. The cubed affects the 2. The cubed affects the x cubed. And so this is as good as saying 2 cubed, all right? Then here x. Now the 3 times 3. I'm taking it from here. So it's as good as saying x cubed, which is going to be x to the power 3 multiplied by 3. All right, that's fine. Over at the bottom, I've got 8 cubed. That's all good and well. Y to the power negative 4 again times 3. I'm respecting this particular rule of exponents. And so we're simplifying without a calculator. 2 to the power 3 is an 8. X to the power 3 times 3 is x to the power of 9 over 8 to the power of 3. It gives me, I think if you look at it, I think it should give you 512 if I'm not mistaken. 5, 1, 12, 8 to the power of 3. And then here you've got y to the power of negative 12. Negative 4 times 3. So without a calculator, this number 4 is simplified to this version. I need to emphasize the importance of laws and following them. Mathematics is about laws and following them. Each particular question, you will use a law or more. So you need to make sure that you remember and acknowledge the laws of exponents. All right, sharp. That's number 4. Write it down on the side. I would like to try maybe number 7, interestingly, and use a couple of laws on numbers. Or let me try number 6, actually. All right, let's see what we can get on number 6 together as a team, together as a family. I want to take this out. Gone, going. It's gone. Somebody raise their hand and I'd like to acknowledge that. Go ahead, please.
Excuse me, sir. I'd
Yes.
like to ask if we could simplify it to 1 and x to the power of 9 over 64 and y to the power of negative 12. But then
Yes.
when you realize that the negative is at the bottom as a denominator, can we take it to the top and then multiply?
Perfect. You can do that. So in other words, 8 can get into 512, so we can extend it further. And then it's x to the power 9, y to the power of 12, all this over 64. Just so everyone can get the idea, you can stretch this further from the perspective that if I say to you 1 over x to the power of negative 3, it's as good as saying x to the power of 3. So when it's 1 over x to the power of negative 3, then you can take it up. Or if you want, you can leave it like this. It's still okay. I actually prefer it sometimes like this because sometimes you guys mess up on this thing. So I prefer that you leave it like this, which is still fine with me. I want to try number 6. I think that's fine. Let me see if you still, yeah, so I think you're good. Let me go further on number 6, right there. Number 6 says 2, then x squared, then y, then 4x to the power of 4, then y to the power of 3, all this over 6x to the power of 6, and then y to the power of 6. If I look at the top, I've got numbers. There's a 2 and there's a 4. If you were to multiply them, I think you should get the number 8. Then there's x squared, then there's x to the power 4. So there's x squared multiplied by x to the power 4. As long as the bases are the same and there's multiplication, the powers add. So I end up with x to the power of 6, 2 plus 4, which gives me x to the power of 6. I also have y, and then y to the power of 3. This is like y to the power of 1, then also y to the power of 3, which gives me y to the power of 4. The powers, they add as long as the bases are the same and there is multiplication. At the bottom, I just have 6, then x to the power of 6, then y to the power of 6 as well. Now, notice that the numbers, 2 can get into 8 and 2 can get into 6 as well. If 2 gets into 8, I'm trying to make it as small as possible. That's 4. And then if 2 gets into 6, that gives me 3. I have x to the power 6. Then at the bottom, also x to the power 6. So they actually can cancel each other out. If you would like, you would have it this way. You can say x to the power, all right, x to the power of 6 over x to the power of 6, which gives you, and because the bases are the same and they are subtracting, or they will subtract, so it's x to the power 6 minus 6, which gives you x to the power of 0. The rule says anything to the power of 0 is 1. So x to the power 6 over x to the power 6, they cancel each other out. And now you're left with y to the power of 4 and then y to the power of 6. So the top power always subtracts the bottom power. Let me show you where the rule comes from. If I said a to the power of m over a to the power of n. Top power. The top power is m minus the bottom power n. So in this case, it's as good as saying y, top power 4 minus bottom power 6. And eventually, you're going to get an answer like 4 over 3, then y to the power of -2. So this could and is your answer. And like I said prior, if you'd like to break it down, this can be written as 1 over y squared, y to the power -2, 1 over y squared right there. And then eventually it becomes 4 over 3y squared. But again, I say, even if you leave it somewhere here, this should still pretty much make it okay. So that's what you have for number 6. All right, I want to try number 7 and we move on to more interesting, crazier ones. The next slide has more. So this one is just basically your hi, how are you kind of questions, you know, nothing too hectic on that one as we go on along. All right, let me see if there's a question somewhere. So can't we convert 6 and 4 into its prime bases? You can, but in this case, it won't really be necessary because you're just simplifying. Most of the time you do the conversion when you are looking for a value of x. And as I go further, you'll be able to see more questions that I do that are aligned to that. Number 7, hope people have written this. Number 7, let's go together on number 7. This is gone. All right. Number 7 says 1 over 4, all this to the power of -3x is multiplied by 8 to the power 2 minus 2x. Let me do some side notes here. Now, it's important to understand that if I write something as 1 over 4, it's as good as saying writing it as 4 to the power of -1. If this was 1 over 4 to the power of 3, I would write it as 4 to the power of -3. So again, the rule that follows, the whole idea is that if it is like a fraction, so as I say 1, here, if I say to you x to the power of -n, it can be written as 1 over x to the power of n. Let me just make sure that my x looks proper. Gone, and then I will do this. That. So I'm going to have this as x to the power of -n is 1 over x to the power of n. So I can quickly, on this part, say 4 to the power of -1. All this to the power of -3x. And then multiplied by, there's an 8 here. Now, somebody before asked about prime bases. That's all good and well. But I want you to understand that with mathematics, you've got to intimately look for relationships. I have an 8. I do have an 8. And from that 8, I can break it down to have it as 2 multiplied by 4. That's what 8 is. To the power of 2 minus 2x. Okay, let's have a learning point here. What am I learning? I know for a fact that if I've got, let's say, 3 multiplied by 2 to the power of x, this is as good as saying 3 to the power of x, all right, multiplied by 2, all this to the power of x. So that's basically the rule that I'm getting. The rule comes from here. If I say a, b to the power of m, it's as good as saying a to the power of m multiplied by b, all this to the power of m. Now, let's do the maths here. 4 to the power of -1 to the power of -3x. It means the -1 will multiply the -3x, and so I will have it as 4 to the power of 3x. All this multiplied by, check this out, 2 to the power of 2 minus 2x multiplied by 4 again to the power of 2 minus 2x. But I can take this further. Remember, they said without a calculator. So I'm afraid of using prime bases, because for you to do that, you needed to change 8 and then you use a calculator. So I'm using my brain together with you. So I've got the 4's this side. I got a 2 there. I've got a 4 as well. Notice that the 2 minus 2x is dealing with this 2 here as well as this 4, just like I put it across here. I'm hoping we're working together on this one. Work with me. It's possible, and I did this because I want to show you something. 4 can be changed to a base of 2. It's actually 2 squared. Then there's a 3x there. I still have my 2 there. Then 2 minus 2x. Again, I've got a 4. I can have it as 2. That's a 2. Then 2 minus 2x. I'm still good with that. Now, I've got the 2's alone now. Everyone is of a base of 2, but we can continue and say, okay, 2 to the power of 2 to the power of 3x is as good as saying 2 to the power of 6x. All right, I'm okay with that. Maybe let me replace the multiply with a dot. I actually like using the dot because it's a bit easier to deal with. Dot right there. Then I've got 2 to the power 2 minus 2x here. Multiplied, interestingly, this 2 multiplies everything. It's as good as saying 2 multiplied by 2 minus x, which is 4 minus 2x. So it's like 2 to the power 4 minus 2x. The bases are all the same, and there's multiplication, and the law says if the bases are the same and there's multiplication, the powers must add. In other words, as I'm ending up my question, is 2 to the power 6x plus 2 minus 2x plus 4 minus 2x. That's what I have at the end of the day. So the powers will add because the bases are the same and there is multiplication. Let me get you guys involved. What do I get at the end of the day? Let me get you guys involved. What do I get at the end of the day? Like this. Oh, this should be 4x. There you are. Sorry about that. So I think I'd written it wrongly here. It's supposed to be 2x. So that should be 4x. All right, so I have this here as 4x. Okay, that's 4x. Can I get you guys involved and you guys give me a question and answer to this, especially the last part, the top part here? 2 to the power, what do I get at the end of the day? 6x plus 2 minus 2x plus 4 minus there. Do I get 2 to the power 6? Please confirm with me. We don't want to make mistakes here. Please confirm with me if that is what you get. Do you get 2 to the power 6? What you get? Is that confirmed? All right, everyone says I get 2 to the power 6. And just so you may know, 2 to the power 6 is actually the value 64. So I'm good with that. 2 to the power 6. Let me try number 9, because number 9 will get me to what I want. There's parts that I need on number 9, and it will help you to understand the next coming couple of questions. Again, I say you are always constantly going to be using the laws to actually evaluate your questions. Laws everywhere. To evaluate questions, laws. To evaluate questions, we use laws without a calculator as it is. I'm taking this out right now in about 5 seconds or so. So I want you guys to really get involved in all of this. All right, gone. Let's try number 9. There's a 4 to the power n plus 2. There's a 9 to the power n minus 1. I see 72 to the power of n, and I also see 2 to the power of 1 minus n. So let's try that. With maths, look for relationships, and we do not have a calculator, so we're going to try our best. The 4 can be changed quickly to a 2. I'm okay with that. There's a 2 here. That's why I'm thinking about it as well. So maybe let me have it as 2 to the power 2 to the power n plus 2. For now, I would like to leave the 9 on its own, and I'll tell you why, because I think something will happen with the 72 at the bottom. So let me leave the 9 there because I'm looking for relationships. Last I checked, in mathematics, if you say 9 times 8, it gives you 72. So I have a situation of 8 times 9. If you use a calculator, it breaks it down into prime bases, which is what they don't want. They will check to see that this person jumped the steps and used a calculator. So hence, don't use it. 8 times 9 to the power of n, which then, and I'm bringing it this side here, and I'm going to start at the top. It's 2, then 2 times n is 2n, then 2 times 2, that's a plus 4. I still have my 9 untouched, unchanged. And using one of the laws I used in the previous question, the 8 then goes with the power n, much as the 9, which I wanted, with the power n. And I still have my 2 at the bottom, 1 minus n. Then I noticed that 8 again further on can be changed. All right, 8 can be changed further on. How so? So I've got the 2 to the power 2n plus 4 at the top. My 9 unchanged. So let me just write this properly so it looks like a 4. 4. Then 9 to the power n minus 1. All of this, the 8 can quickly change into a 2. It's 2 to the power 3 to the power n. So let me do it on the side here so that I can write the final answer like this. So it's like this, which eventually becomes 2 to the power 3n. So here I'll write 2 to the power 3n dot 9 to the power of n dot 2 to the power of 1 minus n. Now at the bottom, I've got the 2's. And there's multiplication at the bottom, whereby I've got the 2 to the power 3n and the 2 to the power 1 minus n. Again on the side, let's see. It's as good as saying 2 to the power 3n plus 1 minus n right there. And I think eventually I'll end up with 2 to the power. So it's 3n minus n, which is 2n plus the 1 that remains. And I still have my 9 to the power n at the bottom, my 2 to the power 2n plus 4 at the top, and my 9 to the power n minus 1. So we're now at a point where the bases look the same, at least the top, bottom. Now, again, I say, if the bases are the same and there's division, top power minus bottom power, top power minus bottom power. So this becomes 2 to the power 2n plus 4 minus the bottom power. Okay, fam, when you're subtracting, do not forget to put the brackets. When you're subtracting, do not forget. When you say minus bracket all the time, it helps you. A bracket will change your life. A bracket will change your life. So here it's now 9 to the power n minus 1 minus bracket, and then n right there. And I check it out now. I'm like, okay, fine. Now I'm good to go. 2 to the power 2n plus 4, open the brackets. There's a negative here, multiplying the 2n plus 2 minus 2n minus 1. We go again, 9, then n minus 1. If you open the brackets, it's minus n. We are almost there on this question without a calculator. Like terms, 2n minus 2n gives you 0. Like terms, 4 minus 1, I get 2 to the power of 3 at the end of the day. Then like terms, n minus n gives you 0. That's 9 to the power -1, 2 to the power of 3, maths, that's 8. Then here, 9 to the power of -1 is like 1 over 9. And finally, your answer without a calculator is the value 8 over 9. Let me know where there's a struggle so I can be of assistance to you throughout the whole time. Talk to me. All right, let's go to the more interesting ones here. So on my next slide, I'm going to give you 2 questions to try. Then we go through them together. Then we move on to another concept over and over again, right? On my next slide, that's what I'm going to do so that I can be able to get you guys to understand. So write this down. I'm taking it out in about 5 seconds, 10 seconds. All right, gone. Thank you. Right there. Now, look at the next slide. I'm going to pick up questions which I want you to try. And I would like you to try actually the first one right there. And maybe another one. I would like you to try number 3. Now, I'm going to give you about 5 minutes for both these questions or less. Let's go for it. I'm going to mute myself while I see what we know and we test ourselves. Go ahead, fam. 1 and 3. 5 minutes. we should be good now. Let's try this together. All right, so we are on question 1 as well as question 3. Let's try this together, fam, and see if we're going to win. Okay. Now, in this one, it says to me 10 to the power of x dot 25, then x to the power x plus 1 over 5 to the power x, and so goes the story. Relationships are everything. Okay, let me see. Let me leave the 10 on its own. I'll tell you why, because I think it becomes a bit easier. There's many ways of doing this, by the way, fam. I can change the 25 to 5 to the power of 2 right there. All this to the power of x plus 1. At the bottom, I do have another 5 to the power of x. And I think I can change 50 to 10. That's why I left that 10. To 10 multiplied by 5. All this to the power x minus 1. I can. There are many ways of doing this again. So then I've got the 10 to the power x. I see you. Then here I've got 5. That means 2 will multiply x plus 1. That becomes 2x plus 2. All of this over 5 to the power of x. We're good. Then here, like I said in the previous questions, it's got 10 times 5. That becomes 10 to the power x minus 1 multiplied by 5 to the power of negative 1. So I'm still pretty much right, 5 to the power of x minus negative 1. Sorry about that. Let me do this, write it properly. So 5 to the power of x minus 1. At the bottom, I've got the 5s, and they're multiplying, so the bases must pretty much add. And what I think is, at the bottom, I will end up with 5, and so this is like x plus x minus 1. So let me write it on the side here. It's like 5 to the power x dot 5 to the power x minus 1, which is like 5 to the power x plus x minus 1, which is 5 to the power 2x minus 1, while I remain with 10 to the power x minus 1 top, 10 to the power x top, 5 to the power 2x plus 2. Then I said the bases, top, bottom are the same. Top, bottom, top power minus bottom power. Let's deal with the 10s. The 10s. It's as good as saying, let me bring it here. 10 to the power x minus, don't forget the brackets. 10 to the power x minus 1. Let's deal with the 5s. Top power 2x plus 2 minus bracket 2x minus 1. Do not forget the brackets. When you open them up nicely here, I've got the x minus x. I'm doing it old school. Then minus and minus gives you a plus 1. Then I've got 5. Then we go for it. 2x plus 2. Open the brackets. Minus 2x plus 1. Right there. Minus 2x plus 1. So then we go. This will give you 0. I remain with the plus 1. Then here again, this is like 2x minus 2x. That gives you 0. Plus 2 plus 1. That gives me 3. This is like 10. 10 to the power 1 is 10 multiplied by 125, which is basically 5 to the power of 3 multiplied by the 10, then eventually 1,250. That should be your answer right there. So I think that should be fine. You let me know where there's a bit of a struggle so I can be able to help you out. That's just number 1. Did you get it right? Just use a reaction and emoji there. Say, yeah, I did. No, I didn't. Blah, blah, blah. Yes, somebody says I got 1,250 with a different approach. Your maths teachers will always tell you there's many ways you can finish it up to kill a cat. So yes, there's many ways. Let me try number 3. quickly. Number 3 is interesting. I want to take some stuff out here. Gone, gone, going, gone, gone. All right, people got this right, so I'm happy about that. We're going to go now and move on to even more crazier things as we're going along. This is gone, gone, going. All right, perfect. Let's try number 3. 9 to the power x plus. This time there's a plus. 3 to the power 2x plus 1. Over 18 to the power x, then 2 to the power 1 minus x. What am I looking for? Relationships. 9 can be changed to 3. I'm happy about that. I think it can be 3 squared, that 9, then to the power of x plus 3 to the power of 2x plus 1. And then at the bottom here, I'll have it as 18x, which I can quickly change to 9 and 2 to the power of x, okay, right there. And then right there, I'll have it as multiplied by 2 to the power of 1 minus x. So I think I'm still okay on this. Let's do the maths. At the top there, it's like 3 to the power of 2x plus, look at this, 3 to the power of 2x, okay, multiplied by 3 to the power of 1. Who is this? Let me help you. So in maths, if I say to you 2 to the power of x multiplied by 2 to the power of 2, it's as good as saying 2 to the power of x plus 2. So the left-hand side is equal to the right-hand side, much as the right-hand side is equal to the left-hand side. In other words, I can break this 2 to the power x plus 2 into 2 to the power x dot 2 to the power 2. Just like here, where it's 3 to the power 2x plus 1 broken into 3 to the power 2x dot 3 to the power 1. So I can break it down. And I have a reason why. At the bottom, let me deal with the 9 to the power x. Let me deal with the 2 to the power x again, and a 2 to the power 1 minus x. Again, further, at the bottom, where there's the 9, I can change it into 3. And so look at this interesting part. So it's 9 to the power x side notes, which is 3 to the power 2 to the power x, all right, which is basically like 3 to the power 2x. So then this is again 3 to the power 2x. I did it even here. I'm just reiterating. And then I've got 2 to the power x. I'm still at the bottom. 2 to the power 1 minus x. Tell me something at the top. You see, the 3 to the power 2x is common. That's my guy. Yeah, it's there. It's common. I can factor it out. Look at this. It's going now. I can factor it out. And so when I factor out 3 to the power 2x from here, I remain with 1. And if I factor it out from here, I remain with 3 to the power 1. Whatever you do in math, you must be able to go back, because I can always go back to this. Look at it. If I say 3 to the power 2x times 1, I go back to this. If I say 3 to the power 2x times 3 to the power 1, I go back to this. I factored out. The same way you'll do it in math. If somebody says something like this, you'll take x on the outside, you remain with 1 right here, plus in this particular case, I'll have it as a 3. So you can do that. So you can always go back, x times 1, that's x, x times 3, that's 3x. That's exactly what I did here. Then at the bottom here, I've got something interesting. The 2, multiplication, the powers they add. So here we are, 3 to the power 2x, still with 1 plus 3 to the power 1, which is 3 by the way, Actually, I can always do this and say here, okay, let me do this. I can always say this is 4, because it's 1 plus 3, which is 4. All of this over 3 to the power 2x. Check the guys at the bottom. It's 2 to the power x dot 2 to the power 1 minus x. In other words, it's supposed to be 2 to the power x plus 1 minus x. Then x minus x, it gives me 0. I'm remaining with 2 to the power of 1, which is 2. And then what? This, they cancel out. Good. Then I've got 2 getting into 4. My final answer is 2. That's question number 3. I'm hoping people are getting this. Right, you let me know. I actually want to do number 7. Yeah, number 7 looks proper for me. I actually want to do number 7. Okay. Somebody says, can you please explain the factoring out part? That's not a problem. So basically what you're trying to do here is to ensure that because they are of the same basis or they're just the same, all you need to do is to take out the 3 to the power 2x. Maths is very elementary. What I mean by that is the same way you do simple things is how you do complicated things. So if I say to you x squared minus 4x, what is common is x. Take it out. It becomes x minus 4. When I open it up, it goes back to this. And when I factor it out, it comes back to this. Same thing here. 3 to the power 2x is common. I take it out. I remain with 1. So that when I go back, I will say 3 to the power 2x times 1. I get 3 to the power 2x. Then 3 to the power 2x times the 3, because when I take it out, I'm removing this 3 to the power 2x. I'm remaining with 3 to the power 1. So I remain with 3 to the power 1, which is like 3. All this over what you see at the bottom there. So it's just definitely how you'd want to put it across. Go ahead. Somebody has a question. I'm listening.
The one that says 3 raised to 2x on step 3 is the one that we call a common factor.
Yes, this particular one here. Yeah, because they are the same, so you'd probably require a common factor. Ne? All right. Let me take this out quickly. I want to do number 7, but I want to show you something before I pretty much do number 7. It's quite interesting. Gone, going, gone. Boom. All right. There's a topic in maths. The topic is algebra. And there's a subtopic known as difference of 2 squares. Difference of 2 squares celebrates the idea that if I've got x squared minus 25, I can write it as x squared minus 5 squared. I can. And when I factorize this, it's as good as saying x minus 5 and then x plus 5. This is difference of 2 squares. Now look at this. Look at what's interesting here. You see, there's an x here. So that's the x part. That's the x5 part. There's a 5 here. So you put a minus 5 and a plus 5. It's difference. So there must be a minus here. In other words, this can't work if it's like this. Please do not make a mistake. This can't work. This is not. Don't be Chuck Norris. This is not x minus 5, x plus. It's not. Difference of 2 squares. Difference, negative. Difference, negative. Let me show you more examples. If I say to you k squared minus 16. Minus 16. So you can see that 16, that's definitely a perfect square. That's definitely a perfect square right there. Then I've got the k squared. So I can make it into k minus 4. I like that. Then k plus 4. Look at this next one. 9x squared minus 36. 9x squared minus 36. I can write this as 3x. Wait. Because you know what? 9x squared can be written as 3x, then squared like this. It can. Like then the 36 can be written as 6 squared. Eventually, I'll have it as 3x, all right, minus 6, difference of 2 squares, then 3x plus 6 right there. I'm happy about that. Look at number 7. Same idea. Number 7. 9 to the power x minus 9 over 3 to the power x minus 3. I want to introduce to you a method, right? Where you become a bit clever when you're dealing with this. Now, don't do Chuck Norris maths, please. Hey, bana. Don't say, yabona mfethu, this goes into that boy. Uyayithola ntwana, faka u3 lapha. Then yashayela into shayela la. Mfethu, don't do that. Don't do that. Where do you get that maths from? Don't do that. Check this out, Chuck Norris. The 9 can change into 3 to the power of 2 to the power of x minus the 9 over 3 to the power of x minus 3. Then I've got 3 to the power of 2x minus 9. All this over 3 to the power of x minus 3. Let me show you the K method. Now, think about it. Think about it. Something is up with these guys. Something is up with this guy. I can't subtract them. I can't. Because there's a minus here. So it's not single units. It's 3 to the power 2x minus 9. It's not on its own. It's 3 to the power 2x minus 9. Much as at the bottom is 3 to the power x minus 3. I cannot just subtract them. But what can I do? What if I said, let K be 3 to the power x? Say, let K be the... Why are you doing that? I just want you guys to see the visual part of things. Let K be 3 to the power x. Check this out. So at the bottom here, instead of 3 to the power x, I can write K minus 3. At the top here, instead of 3 to the power 2x. Now, work with me. Side note. If I say 3 to the power 2x, it's as good as saying 3 to the power x multiplied by 3 to the power x. And if 3 to the power x is k, if 3 to the power x is k, then this becomes k times k, which is k squared. Which is k squared. All right? So at the end of the day, I'll have this as k squared. This 3 to the power 2x minus 9. Difference of 2 squares right here. It becomes k minus 3, all right? K plus 3, okay. All of this over k minus 3. And I think that this can now cancel off with that. Eventually, I'll have it as k plus 3. But what is k? Is 3 to the power x plus 3. So when you have simplified, your answer becomes 3 to the power x plus 3. All right, let me help you. Don't worry, I got your back. Let me write this down. I'll show you how it's done. I see people saying, we are lost. We are lost. Don't worry, I got your back, Antoine. I got your back. All right, let me write this down and I'll show you how it's done. All right, somebody says we're getting lost. Can you elaborate? And all. All right, let me start. Don't worry. Let me do this from scratch. I'm gonna take this out. Gone. I was teaching you about what is known as difference of 2 squares. I have the idea that if I've got x squared minus 4, I could write it as x squared, then perfect square is the 4, 2 squared. And when I factorize it, math allows me to say x minus 2, x plus 2. That's all good and well. I could have a situation of k squared minus 49, which I could quickly write as k, the squared being outside, minus the 7 squared being outside, which mathematics allows me to say k minus 7, then k plus 7. I could have 4 x squared minus 36, which I could write as, see, perfect squares, 2x squared. As long as you can make it into a perfect square, 6 squared, and maths allows me to have it as 2x minus 3, 2x plus 3. And then I'm saying to you, here is my situation. 9 can be written as 3 to the power 2x. 9 to the power x can be written as 3 to the power 2x. At the bottom, I've got 3 to the power x minus 3. I've acknowledged that particular situation. Do not be Chuck Norris, please. And then I'm saying to you, did you know that when I say 3 to the power 2x, it's as good as saying 3 to the power x multiplied by, it's as good as saying that. And I'm saying, okay, bottom and top, something is happening on the bottom and top part. I see that I can make 3 to the power x and then 3 to the power 2x somehow related. And I'm saying, I'm introducing the K method. I'm saying, okay, make your life easy. Can't we say, let the K be 3 to the power x? What it means is that wherever there is 3 to the power x, I will put K. So at the bottom, it's going to be K minus 3. At the top here is 3 to the power 2x. And 3 to the power 2x is like 3 to the power x, 3 to the power x. What is 3 to the power x? K. It's like k times k, which is basically k squared minus 9. K squared minus 9. I'm hoping we're getting this. Then I'm reminded, oh, k squared minus 9. K squared minus 9. It's as good as saying k squared minus 3 squared. And maths allows me to say k minus 3, k plus 3, difference of 2 squares. And so now I'll have it like this, all of this over k minus 3, eventually gone, and I'm left with k plus 3. But hold on, stop the bus. What did we say k is? It is 3 to the power x, eventually plus 3. The question said simplify. So that becomes your answer when you do that. And then that's 3 to the power x plus 3. All right, talk to me, fam. Write this down. I'll do more of these things. And you know what? Why it's important is because this topic, like all other topics, they're all cemented on the topic algebra. Without algebra, you pretty much can't do any maths. Algebra is the mother of mathematics. Go ahead, I'm listening.
Excuse me, sir. Can you please what's it called? Can you please like explain on how you can identify when to use the K method and when not to? Because somebody could have easily tried to break down the 3 raised to 2x. So yeah.
Okay, cool. So usually, and thank you for that question. Usually when you're dealing with the K method, it's under situations where there's something like this, a 3 to the power x and something which is 3 to the power 2x. So the powers here, this will be double of x. This will just be x. That's when and they have the same base. That's when the K method would make sense. In my next set of questions, you'll see how it comes back together. It's quite interesting, actually, when I do more questions, especially the ones to do with factorization. It's going to be a crazy time when I do the next part of my lesson. So, and whenever you've got something with 3 to the power x, there's an x and a 2x, and they have the same base, I suggest K method. One more time. Same base, 3, 3. The power x, the other one, double it, 2x. K method is your guy. K method is your guy. Right, perfect. That's the first part there. I'm taking this out. Gone, going. All right, let's try exponential equation. Subtopic, exponential equations. Please write that as a subtopic. These are more interesting, a bit more challenging, exponential equations. Please write that one as a subtopic. Engage with me, learn with me, work with me. Now, there are two types of exponential equations. The first type is equations where the exponent is unknown. So all these equations that you see as examples here, the exponent x is unknown, the exponent x is unknown, exponent x is unknown. So at any particular time, we don't know x. So the type 1 of exponential equations are those where you don't know the exponent. Now, these questions are typical exam type questions, and newsflash, I took them from exam papers. Pretty much. The question says, if x is an element of real numbers, solve for x. So we are not simplifying here. We are solving for x. It's different from what we did before. Before, we would simplify a whole complicated thing, but this time we must come out with an answer for x. X is 5, x is 2, x is -3. We must have a value for x this time. All right. Let's start with number 1. 4 to the power x minus 1 is equal to 8 to the power -1. They're equations. That's why they're equal signs. They're equations. Relationships, that's for me is key, right? Relationships, that for me is key. And we're saying to ourselves under relationships, I can change the 4 to a base of 2. I can change it. The 4 to a base of 2. In other words, it becomes like this. It's 2 to the power 2 to the power x minus 1. I can change the 8 to a base of 2 again, 2 to the power 3, then to the power -1. Maybe somebody is asking, but say, how do you know this? How can you, what if it's a big number? How do I know what I can do to change the base? No problem, Chuck Norris. I got your back. Say 8 in the calculator equal to, say 8 equal to shift, then fact. There's a pattern with like a comma somewhere there, or factinyana. It should give you something like 2 to the power 3. You can do anything anyway. You can even say 32 equal to shift to the fact is 2 to the power of 5. So you can do anything. All right. So the bases are now the same. So this becomes 2. Then you multiply 2 times x minus 1 is 2x minus 2. It's like this. It's like this. It's like this. You open up the brackets, basically. Then check this out. 2 to the power 3 to the power -1. This is as good as saying 2 to the power -3. Now, here's the key to answering these questions. The whole idea was to get to this point so that the bases are equal. Then what do? Drop the powers. Drop it like it's hot, man. Once the bases are equal, drop the powers. There you are. 2x minus 2 is equal to -3. Then this becomes 2x is equal to -3 plus 2. We're doing math. That becomes -1. 2x. Finally, the value of x is -1/2. That's question number 1. Now, when I say to you guys, you can change it. 8 equal to shift blah blah. I only know it using the Casio. I don't know how to use the Sharp calculator on that. If someone has knowledge, please do send a text on the group so that we can have an idea. I'm really sorry about those that are using Sharp. Sometimes Sharp is not that sharp. So please, can you Casio calculate? Ngiyadlala, heart. You know, so right, x is equal to -half, so I'm good. So let's try number 3, fam. Let's try number 3. I'll give you some to try. Let's try number 3. Let's work together on that one. You can always relax in the class. I'm very animated and I'm also relaxed. You can't learn maths like serious. Yeah, this thing will cause mental blisters here. So we gotta go softly, nicely, casually. But while we're being casual, we're learning. Shout number 3 point. Number 3. Number 3. Number 3. 3 to the power x, I see you. 3 to the power x plus 1, I see you, is equal to 27 to the power x. 27. Go ahead, talk to me. You know what I'm thinking. 27, man. Yeah, dog. I'm supposed to change it to now. What's scream fit? I'm supposed to change it to 3 to the power 3. 3 to the power 3. And then right there to the power of x. I think we're doing well on that one, right? Right? So there you are. And then here on this case, I've got 3 to the power of x dot 3 to the power of x plus 1. The bases are the same, ne? So there's multiplication and then the powers should add. It's x plus 1, which is 2x plus 1. Then here it becomes 3 to the power 3x, then 3 to the power 2x plus 1. I can drop the powers because now at the end of the day, we have the same bases. 2x, drop it like it's hot, then 3x there. I'll take 2x to the other side. 1 is equal to x. Siyabangena. So let's increase the tempo. Number 4 point. Engel. Okay, sorry. Number 4 point, Engel. All right. Let's go for number 4. Right, you let me know where there's a struggle. I'm about to give you more on this. You let me know where there's a struggle. All right, the number 4. Number 4 is quite interesting, actually. So let's go for number 4. All right, I'm about to take this out. 1, 2, 3, 4. It's gone. Gone. And then number 4 is interesting. It says 2 to the power 0, blah, blah, blah. Let me write it as I see it. 2 to the power 0 plus, check this out. I can break it. 2 to the power x dot 2 to the power -2. What are you doing? What are you doing? So look at this, fam. I remember telling you, Uti, when things are like this, you can always write them like this. Because mathematically, this side is as good as saying 2 to the power x plus -2, which leads me to the same place like this. So I end up at the same place. So I can always do that. And then here, I can break this 2 to the power x plus 1 easily as 2 to the power x dot 2 to the power 1. Then finally, there's also a 2 to the power x, and apparently it's equal to 53. Now, 2 to the power of 0 is 1. That's a number, it's 1. So when I take 1 to the other side, I'll end up with 52. Because 53 minus 1. Then notice something about these guys. Notice something. 2 to the power x is common about these guys. 2 to the power x is found here. 2 to the power x is found here. 2 to the power x is found here. It's common with these guys. And then now I can take it out and I end up with 2 to the power -2 when I consider this. Take out 2 to the power x from here. I'll end up with 2 to the power 1. I think there's my plus there. There's my plus. I respect that. And now I'm here. There's a plus and that's 1. That's 1 right there. so that you can always go back. You see, again, I emphasize the importance of being able to go back. It's important that you go back, because I can always open up and say, okay, 2 to the power x times 2 to the power negative 2, I end up here. I can always go back, 2 to the power x times 2 to the power 1, I end up here. I can always go back, 2 to the power x times 1, I end up here. I can always go back. And now when I do the maths, work with me, fam, work with me. 2 to the power negative 2 plus 2 plus 1 is actually 13 over 4. That's what it is equal to. 13 over 4 right there. And then now notice this. Let me show you something from basics, okay? Let me show you something from basics. If somebody says to me 2 to the power x multiplied by 3 right there is equal to 15. It's just a loose example. I can always break down and divide both sides by 3. I'll end up with a 5. This is just a loose example, okay? Nothing hectic, just a loose example. So I can divide both sides even here by 13 over 4. I can always say 52 divided by 13 over 4. I get the answer 16. And then here I remain with 2 to the power x. I can always do that in maths. Divide by 13 over 4. Then 2 to the power x is now equal to 2 to the power 4, because to prime basis, 16 is 2 to the power 4. Drop it like it's hot. Eventually, your answer for x is equal to 4. And I'm going to unmute someone. Go ahead. I'm listening. Okay, seems we're not getting through. That's
So
all.
what did you get 52? Because on the first step we've got 53.
Okay, maybe I can't hear you, so maybe just rephrase your question. I can't hear you.
So what did you get equal to 52? Because in the question we have got to 53.
Exactly. I said 2 to the power 0 is 1. Ne? Then I took 2 to the power 0, which is 1. I took the 1 to the other side of the equal sign. So 53 minus 1, I end up with 52. Is that okay? Okay.
Oh, yes, sir. Thank you.
Okay. All right. So here we are. We're good to go. And then that's what you have. So it was 53, yes. Now it's 52 because 2 to the power 0 is 1. I took 1 to the other side, and eventually I pulled through. Somebody has just posted how to do it on a sharp calculator, so it's fine. You can just follow suit on that one. Okay, fam, let's try another question. Right, I'm going to start with this. Let's try number 6. Number 6. Then I'll give you 2 questions after I've done number 6. Number 6 is quite an interesting one there. All right, so somebody's got a hand. Go ahead. I'm listening.
Excuse me, sir. So is multiplying both sides by 13 over 4 not unnecessary if you can just see that the 2 to the power x is multiplying itself by the 13 over 4. So obviously if it goes to the other side of the equal sign, it's going to be dividing, and you don't have to say 13 over 4. Huh? Yeah, that.
Okay, so let me try and get this right. You're saying to me, if I take this, I can take this to the other side. I think you've muted yourself. Let me try and, yeah, go ahead. I think I've unmuted you now.
Yes, sir. I'm saying, yeah.
I can't take 13 over 4 to the other side. It's multiplying. I can't. It's like saying this. Like saying 2x is equal to 4. Then you say, okay, but you can take x to the other side. You can't. You can only divide by 2 because there's a multiplication sign here. And another thing that you can't do, you can't say 2 to the power x times 13 over 4. Do not be Chuck Norris. I'm not saying you are, but I'm saying don't be,
Okay,
just
sir.
in case. Somebody says, I'm going to Chuck Norris this question. Wahambu too. wahamba 4. Angeke. Kanjani? You can't do
Okay.
that because these are not the same bases. Impossible, right? So
Okay.
basically, that's what you get. I'm hoping that you're getting the idea. Ne? So that's why I'm saying you divide everything by 13 over 4. Divide by 13 over 4. Right. Thank you so much, fam. Let's try number 6. Number 6. Gone, going. Gone. There you are. All right, I'm hoping people are learning. All these are past exam papers, by the way. Aboma, 4, 5 marks. You know, they want all the working done so that people can understand, can get to know what's happening and all in all. Number 6. 7 to the power x minus 2 is equal to 2 to the power x minus 2. The bases are not the same. The bases are not the same. The bases are not the same. There's a 7, there's a 2. The powers are the same. The powers are the same. The powers are the same. Let me show you some maths. Welcome to school. Check this out, fam. I got your back. I got your back. Now, if I say to you A over B to the power of M, you would say it's like A to the power of M over B to the power of M. I agree with that. The problem here is that the bases are not the same. The bases are not the same. So how do I handle this? Let me show you maths. I can divide both sides by 2 to the power x minus 2. Here I'll remain with 1. I didn't do anything wrong. I didn't do anything wrong. Let me show you, Dwana. This is what I did. Like this. This is what I did. This is exactly what I did. I divided both sides by 2 to the power x minus 2. That's what I did. Say. And then, right, look at this. Look at this. Look at this. You see, the powers are the same. The powers are the same. So I can write this as 7 over 2, okay, to the power of x minus 2. I'm correct. Is equal to 1. Hey, but say, the bases are not the same. Again, say, okay, we hear you. We hear you. You are saying, because they've got the same powers, say, so you can write it this way. Yes. But say, there's still 1. Then let's become clever. Anything to the power of 0 is 1. Anything to the power of 0 is 1. Say, let's be clever. Anything to the power of 0 is 1. Check this out. Anything to the power, I'm correct. I'm correct. Because 7 over 2 to the power of 0 is 1. I'm very correct. 7 over 2 to the power of 0 is 1. And so at the end of the day, the bases are now the same. Like it's hot, you drop it. X minus 2 is equal to 0. Maths, x is equal to 2. That's how you get your answer. That's how you get this thing done. Talk to me, family members. Talk to me. Now, let me know where you're lost so I can be able to find you. That's the best thing possible, right? So that you can be able to work with me on that. So it's 7x. It's a matter of you manipulate math. You take advantage of what you know. Manipulate math. I divided by 2 to the power x minus 2 so that I can remain with 1. Because 1 is manipulable. There's no word like that. I can manipulate 1 into anything. Because in mathematics, anything to the power of 0 is 1. I can manipulate it. So hence I divided by 2 to the power x minus 2. So that on the right-hand side, I remain with 1. And because the powers are the same, then I'll say to myself 7 over 2, respecting this law, is equal to 1. And what is that 1? 7 over 2 to the power of 0. Then drop the powers and x becomes equal to 2. Someone says, I found -2. No, it can't be, because even if you put it here, it can't be. Because when you put x as 2 here, 7 to the power of 0 is 1. X is 2 here, and then 2 to the power of 0 is also 1. So 1 is 1. So no, it can't. It has to be 2. That's basically what your answer is. So it was a matter of manipulating maths. This you do, especially in situations where the bases are not the same, and you're trying to work your way out of that. Okay. I love it. I love it. Okay, I'm ready. Let me try and jog your mind on this. Let me have you try number 2. Let me have you try number 5. Let's go. 5 minutes, fam. Number 2, number 5. Please let me know if you still have a question, still struggling with something. I got your back. I want to make sure that you understand, but I also need you guys to work with me and we pace it up so that we can cover quite a lot of work in a short amount of time. All right, I'm taking this. I'm going to mute myself while I have you do number 2 and 5, and I'm going to give you about 5 minutes. Let's go. We should be okay. I'm on number 2. 5 is so ugly. 5 to the power x minus 2. And then here to the power x. All this is equal to 125. So that's basically what I'm seeing there. 5 then to the power there. Now 125 can be changed to 5 to the power 3. Then notice that this x minus 2 must multiply the x. So in other words, there's x minus 2. All this multiplied by the x. So eventually now you got 5. Then it becomes x squared minus 2x. So I've got it as x squared minus 2x. Then I can drop the powers. So I've got x squared minus 2x is equal to 3. This is like x squared minus 2x is now quadratic. All right, fam? Quadratic, 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 right there. And then minus 3 is equal to 0. It's now a quadratic equation from factorization in maths. You can use the quadratic formula, but I don't suggest it in such a case. You can use it, you'll still get the same answer. So I think when you do the factorization, and remember, I'm going to do this, I'm going to do a full comprehensive. When I start my lessons on the 26th, we'll go through every topic proper and very effectively. So what numbers can I put here? You tell me, you tell me, you tell me. What numbers can I put here to make it work so that it works out? Do I have minus what, plus what? Can I have minus 3, then plus 1? I think I'll get x as 3. Thank you, right? And then the other one, I'll get it eventually as x is negative 1. So these are your answers at the end of the day. You've got x is 3 to the power, x is equal to 3, and then x equal to negative 1. So that's what you get for question number 2. Right, thank you so much. Really appreciate on that one. Okay, let's try number 5. Just want to see if people are winning. Let's try question number 5. So gone, gone, going, gone. Boom. 3 to the power x. All right. Ooh, interesting. 3 to the power x again, but this time over 2 is equal to 7.5. That's what I'm getting. All right. 7.5. That's what you have right there. Now, if you notice something, 7.5 actually is 15 over 2. It's like a mixed fraction. So it's like 7 times 2, which is 14 plus 1. That's 15 over 2. So I'm not so sure if you guys get that, but that's definitely 15 over 2. There's many ways of killing a cat. And so don't worry, we will be fine when we do this one right here. Now, notice you got 3 to the power x. Then you also have, in this part, 3 to the power x over 2. The problem for me is actually the 2 at the bottom. That's where my predicament is. The 2 is a problem. Here, this one here. Now, in maths, you want to get rid of 2. Why don't you cross multiply everything by 2? You cross multiply every single thing by 2. So you'll multiply this part by 2. That becomes 2.3 to the power x plus, again, you cross multiply. Okay, let me do it old school so that people can see where I'm coming from. You want to get rid of the 2, ne? So I'll cross multiply. I'll multiply this by 2. Multiply this by 2 as well. Then multiply this by 2. So then this becomes 2. Then 3 to the power of x plus 3, because this and this will go to the power of x is equal to this, and this will go 15. I just got rid of 3 to the power of x. I see a message that keeps popping. I will explain. And also you can watch the video because I'm going to put it on YouTube anyway, because I had moved a bit further on this one. So then now you've got 2.3 to the power x plus 3 to the power x is equal to 15. Okay. What can I do? Well, what's common is 3 to the power x. Take it out. That's a 2. So I've taken out the 3 to the power x from here. I remain with the 2. Take out the 3 to the power x here. It remains with 1, which is equal to 15. Then now I've got 3 to the power of x dot 3 right there is equal to 15 right there. I don't like this question the way it looks like here, but then eventually that's what I'll have. Then I'll have this as 5. Then 3 to the power x is equal to 5 right there. And then what do I do now? Let me see here. I don't like how this question looks because it'll end up not giving. I wanted to have a 3 here. This would have been better if this was 5. So, nah, I don't like the way it looks. Right, so eventually fine. Mathematically speaking, you'll get here to 3 to the power x is equal to 5. In such a case, you'd have to use logarithms to actually solve this question. But because you guys have not done logs, I want to pause here. If you got it to this part, I'll recheck where this question I took it from because I don't like how it's looking like here. But you'll end up getting 3 to the power x is equal to 5, and then you need to use logarithms to get your x. And so I will stop here because the bases are not the same. It's not, the logarithms are a greater part of what you'll do later under the topic financial maths. For now, I'll stop here because this question just allows me to get to this part. So I'll just leave it here for now, and then we'll take it up from there. So that becomes what it is at the end of the day. As long as the maths is fine, I think we should be okay. I just want to see if anything is different here. Then there's a 5. Okay, I see your hand. I'm coming up to you. And then we cross multiply. That's a 2. And then there's a 2 there. And then the 15, the 2, and so goes the story. Let me hear what someone else has to say. Go ahead. Yo. Did I miss you? Okay.
I carry 15. Aren't you supposed to, like, you do not divide 3? You do not divide by 3. You say 3x times 3 to the power 1 is equals to 3 squared. And then you remove the bases.
Say that again.
Then it will be 3.
Say that again. You're saying 3 to the power x and 3 to the power 1?
You say 3x times equals to 15. And then you divide it by 3, right?
Yes.
To get 5.
Yes.
So when we're supposed to say 3 to the power x times 3 to the power 1 is equals to 3 squared. No.
You see now. I'm glad you saw that yourself. All right. We're on the right track. Don't worry, you'll be fine.
Yeah, I get it. Thanks.
You see that, ne? Yes, we'll end up at the same place, me and you. All right. Let's go further. Thank you for those ones here. I really appreciate your questions. Let's try the next page. I want to show you something on the second type of equations there. Let's see. Yes, type number 2. Type number 2 says these are equations with the base as the unknown. These are the equations where the base is not known. Now, look at the difference between what I'm going to write here. 2 to the power x is equal to 8. And then x to the power 2 is equal to 8. So if you look at this, the first part, what we don't know is the exponent. The second part, what we don't know is the base. So the next set of questions or exponential equations are those where the base is unknown. But then there's a flip side to it. There's an interesting part to it. It says to me, if x is to the power m over c is equal to c, where c is any constant, then if m is odd, if this power here is odd, then there's only one solution. I want you to remember this. X to the power m over c is equal to c, where c is any constant. Then if m is odd, it's an odd number, then there's only one solution. But if m is even, then there are two solutions, a positive one and a negative one. That's quite important there, right? So that at least we can pull through from there. Again, I go. The second type of exponential equations are those ones whereby you don't know the base and you're looking for the base and you're working towards the base and we're taking it up from there, right? So check this out here. It says if m is odd, if it's m over c and m is odd, then there's only one solution. But if m is even, there are two solutions. One is positive and one is negative. Let's try this piece of information. Let's do number one example. 2 to the power x to the power 2 over 3 is equal to 32. Solve for x. Now, the base, we don't know, it is x. That's an equation with the base unknown. Let me do math. I can divide both sides by 2. I can. And I'll end up with 16. I can divide both sides by 2, and I'll end up with 16. But how do I get the x then? Listen to me and listen carefully. You power by the reciprocal. You power both sides by the reciprocal. So it's x to the power 2 over 3 is equal to 16. Power both sides by the reciprocal. In other words, this is like this. Say, what do you mean reciprocal? When you say reciprocal, you're saying if the power is 2 over 3, you power with 3 over 2. The other way around. 2 over 3, flip it. 3 over 2. You power both sides by the reciprocal. Why? Why, say? It's because this part will end up as 2 over 3 multiplied by 3 over 2. And I'm still going with this, 16 to the power 3 over 2. Then mathematically, 2 over 3 times 3 over 2 gives you 1. So it's x to the power 1. Then here 16 to the power 3 over 2. X to the power 1 is like x. Then you put your calculator on and say 16 to the power of 3 over 2. And the answer for x is 64. You power by the reciprocal. 2 over 3 to the power 3. You power by the reciprocal. That's very important to understand in all circumstances. All right, talk to me where there's a problem. I got your back. I want to make sure that I get you to a point of fully understanding. So 2x to the power 2 over 3 is equal to 32. And you end up with dividing everything by 2. Then you end up powering everything with the reciprocal. 2 over 3 to 3 over 2. Right. Let me just do number 2 just on the side. I know you guys are trying to write, but can you just pause a bit? Look at this one. Look at this one. Still, we don't know the base. That's 64. Again, you power by the reciprocal. Power by the reciprocal. If it's negative 3 over 2, it's going to be 2 over negative 3 is equal to 64 to the power. You can even write it as negative 2 over 3. It's still the same concept, right? There you are. And then these two, negative 3 over 2, there you are, times 2 over negative 3. They'll give you 1. They will give you 1. So this is like x to the power 1, which is x. Then calculator version. Then we say to the power of negative 2, again, over 3. But there's something interesting that you guys should see, and I want to show you where it's coming from the previous question. I'll come to it. Now, look at this. Look at this. We say to ourselves, okay, let me finish this up here. What do you get as an answer for here? Let me involve you. What do you get?
Error.
Error. Hey, man. Error. Wait. I get 1 over 16. Yeah, I also get 1 over 6. I get 1 over 16. Perfect. Yeah, it's actually 1 over 16 when you put it across there. That's fine. And then, so that becomes your answer for this. Now, I want you to compare these two answers here and see something. We said if M is odd, then there's only one solution. Here, it's odd here, right? So there's only one solution, which is this. But if M is even, there you are. There's two solutions. One is positive, one is negative, plus or minus 64. So that's where the bulk of the stuff is. I'm hoping you guys are getting the idea of all of this so that you can see where it's coming from right there. So this is what happens when you have the X being unknown. You always power by the reciprocal. So that's just question 1 and question 2. Look at question 3. I actually want you to do question 3 and question 4 as well. Yeah, 3 and 4. Then I'll move on to the next part, which is factorization of exponential equations so that everyone can understand. Right, this is taking longer than anticipated, but it's fine. As long as we're getting the whole idea, I'm okay with everything. Okay, going. It's gone. You're doing question 3 and 4. I'm taking this out. Gone. Gone. So you guys are going to do question 3 and 4. I'm giving you 3 minutes. Go for it. Why are we saying plus or minus 64? Is because M is even. See, the power here is even here. It's 2. The M, the guy at the top, is an even number. So therefore, one of your answers should be positive. You have 2 solutions, one positive and one negative. So that's the rule. Go for 3 and 4. We should be done. Let's try it. Number 3, 3x to the power negative 5 over 3 plus 16 should be 112. We're looking for x. It's possible that you can take the 16 to the other side. So it's 112 minus 16, which gives you 96. Then 3x to the power negative 5 over 3. Also possible that you can divide everything by 3. That gives you 32, negative 5 over 3. And then now I can power by the reciprocal, both sides. So that's negative like this. We can do the same for 32 to the power negative 3 over 5. And I think it works if you do that. And I think you should get an answer like, I got 1 over 8. You confirm with me if that's what you got. 1 over 8. That's what I got right there for number 3. 1 over 8. Is it 1 over 8? Confirm with me, fam, if you got 1 over 8. All right. Yes, yes, yes. How did I get 32? Someone's asking, I divided both sides by 3. There's a 3. Divide 96 by 3, you get 32. So that you can remain with x on its own there, and then you reciprocate to the reciprocal, and then eventually you're winning. X is 1 over 8. All right, let's go further on that one. Okay, let me try number 4. It's x to the power 4 over 3 is equal to 16 over 81. I think this one is pretty much straightforward. There you are. And the numerator is even, so I must have 2 answers there. And then I reciprocate everything, reciprocate to the power of 3 over 4. I'm not so sure what you get, but I can try it also as well on my side. That's 16 over 81, all that to the power of 3 over 4. What you get, fam? What you get? Tell me. Let me involve you. What do you get? 3 over 4. I'm getting 8 over 27. So it has to be a plus and a minus because there's 2 answers there. All right. Thank you. Plus or minus 8 over 27. So basically, that's what you have. Let's try the next part. So these parts are the parts whereby you only have a situation where you don't know the value of x. Now, the last one, just as a hint, the last one is quite simple. You see, look at elementary mathematics, the last one. If I say to you in maths, x minus 5, x plus 3 is equal to 0, it means x minus 5 is equal to 0. So it means x minus 5 is equal to 0. Or x plus 3 is equal to 0. The same way here, x and a quarter minus 5 will be equal to 0. And x and 2 over 3 minus 4 will be equal to 0. Then you solve it out. So that's not too hectic, I'm hoping. All right, so we're good there. I'm taking this out. Look at the next interesting parts of what we're doing. All right, so this was just practice questions. Let me see. I'll just pick out 2 that I want you to try. Maybe 3 questions quickly that I want you to try. Let me see what I want. Oh, I need to teach you this. Oh, I need to teach you this. Did you know in maths, when you say square root of something, it's like saying 2 to the power half. In maths, when you say square root of anything, it means 2 to the power half. So when I say 2 to the power x is equal to square root of 2, I'm saying square root of 2 is 2 to the power half. Even if you say root of 7, 7 to the power half. Root of 20, 20 to the power half. So the bases are the same. Drop the powers. It's just a simple practice exercise. X is just a half. Let me just jog your mind a bit as well on number 5. Just in case. On number 5, 0.375 to the power of x is equal to 9 over 64. I think this is one of the first times we are actually finding a fraction or a decimal. If you were to just say 0.375 in your calculator, né? If you're just going to say that and say equal to, you should get a number like 3/8, just so that it looks like something that you know. 3/8 to the power of x is equal to 9/64. This is a very interesting one as well. Work with me, fam. Work with me. Say, Anje, 3/8, 9/64. The bases are not the same. I agree. There's a 9 at the top here. There's a 3 at the top. 9, 3, 9, 3. 9 is 3 squared. There's an 8 at the bottom. There's a 64 at the bottom. 8, 64, 8, 64. 64 is actually 8 squared. That's what 64 is. It's 8 squared. And so now I'm going to manipulate this side. The bases are different, but the powers are the same. So this will be 3/8 to the power of x. Then on the right-hand side, I can always do it this way, to the power of 2. Mathematically, I'm very correct. So there's 3/8 here, and now 3/8 there. Now the bases are the same. Your answer is x is equal to 2. That's your answer there. Right? Quite an interesting one as well. Your answer is x is equal to 2. I want you to try number 8. I want you to try number 8, actually. Let me know, fam, where there's a struggle. Got your back. Number 8, right there. Number 8. Here we go. Let's do it together. I think I'm thinking like you here when I say change 9 to 3 squared. And then now you've got 2 to the power x minus 1 dot 2 dot 3 to the power x. Okay. And then what? What do I do here? Because I don't know who this is equal to. I don't know where this is going and what. What if I divide both sides by 2? Or let me get the 2's on their own and the 3's on their own. But I can't just do this, which is what I was saying to you guys. You can't just make things jump and then suddenly they're dividing or multiplying or adding. So here's what I would do. I'm going to do it old school first. If you don't understand it, I'm going to show you the shortcut method. So this is 3 squared. This is 2 to the power x minus 1. I'll divide both sides by 2. And I'll end up here with 2. Like this. Is equal to 3 to the power x. Then I will then divide both sides by 3 to the power 2. All right. So then this then becomes 3 to the power x over 3 to the power 2. It works pretty much the same way. All right. So let me go back. I really want the 3's on their own and the 2's on their own. Maybe my life will become a bit easier. The 3's on their own, the 2's on their own. So how do I break it down? So if I say 2 to the power x minus 1 over 2, and I say 3 to the power x over 3 to the power 2, check what I'm going to do now. This power at the bottom is 1. So it's like 2 to the power x minus 1 minus 1. And this side is like 3 to the power x minus 2. Okay, there's a minus. Let me just put a bracket so that I can remind you that you always put a bracket there. Then eventually, this is like 2x minus 1, which is 2 to the power x minus 2. And then on the other side is 3 to the power x minus 2. Now look at something interesting. Ne? This means, and it goes back to a question that I did. Someone was asking me consistently to say, please do that question because my screen froze. And I'm doing the same thing now. The bases are not the same. The bases are not the same. But I can always manipulate maths. I can divide both sides by 3 to the power x minus 2, then I'll remain with 1. And then now, this, because the powers are equal or are the same, you can always rewrite it like this. Then change 1, because 1 can be changed to anything. So now I've changed 1 to 2 over 3, because I got a base of 2 over 3 also here, to the power of 0. Then x minus 2 is 0 after dropping the powers. So eventually, the value of x is 2. Did you guys get this? Did you get this? Talk to me. Yes or no? You can just type and say yes or no or whatever. So I have an idea. Somebody says yes, somebody says no, somebody says yes, somebody says nope, 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 nope. I got your back, and I'm hoping that you understand. So the point is, don't be afraid of things that look very different. You're still going to get the same place, get to the same place. And I mean, I was manipulating the whole idea that, okay, let me put the 2's alone. Sometimes I usually tell my students, Uti, just do this. It's quite shortcutting if you do this. So you have this like this. Then I say to my students, as in, let me use a different color. Take this here and take that there, so that it becomes 2 to the power x minus 1. That's 2 over 2, then 3 to the power x, then that 3 over 2 over 3 to the power 2. So that's what I usually say, which is basically this part. It's just a shortcut method to that. Get the 3's on their own, get the 2's on their own, and then manipulate mathematics in the sense that you want to ensure that eventually this becomes 1, especially when the bases are not the same. Especially when the bases are not the same. And I'll tell you the key to maths. Maths is practice, Buffett. Practice, 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 practice. You will be fine. So that becomes your answer. And all these are past exam papers, by the way. All right, let me go to my factorization, which is the last part under exponents. And then I think we should be pretty much okay. I'm looking at our time. Wow. Okay. We'll see what we'll do from there on. All right, I'm taking this out. So I'm taking this out. Let's go to our next question right there. This one. All right, examples involving factorization. Let's start there. I want to teach you something. And again, all these are past exam papers. Examples involving, these ones are where the biggest marks are. Sometimes they can go to 6 marks in the exam, such types of questions. Examples that involve factorization. All right, it's possible that when you're dealing with exponents, you could end up having a trinomial. In other words, you could end up having an equation with 3 terms. Let me try example 1. I took this from a grade 12. I know this question. From a grade 12 paper. Remember, exponents, algebra, and all that is examinable in grade 11 and grade 12. And it's going to be 25 marks. In grade 12, it's 25 marks. Between 25 to 30 marks, sometimes between 20 to 25. Your algebra, paper 1. Still pretty much the same number of marks in grade 11. So there is no way you can pass grade 12 without passing grade 11, or at least understanding good basics in grade 11. If you ask me, I will tell you almost 50 to 60% of what you do in matric final exam is what is done in grade 12, in grade 11. So take grade 11 super seriously. You fail here. People don't fail matric in grade 12. They fail it in grade 11 or grade 10. You miss the turn. You off-ramp the wrong way and keep traveling. Off-ramping the wrong way in grade 10, travel. Grade 11, travel. Grade 12, you will never arrive at your destination. You lost it in grade 10. You lost it in grade 11. Fix it now, Chuck Norris, while it's still fixable. Don't take these things for granted. Fix it while you can still fix it before it's too late. Boy. Summon number 1. 2 to the power 2x plus 6.2 to the power x. All this is equal to 16. Okay, so there was a time when somebody asked me, say, when do I use the K method? And I said, okay, if you've got something like this, you know, because I see on the side, I've got 2 to the power x. I also see on the side, I've got 2 to the power 2x. And so I can always say, let the value of k be 2 to the power x, so that it makes a bit of some sense. If I do that, then this guy should become k squared. And let me justify that. 2 to the power 2x, 2 to the power 2x, when you write it nicely, is 2 to the power x dot 2 to the power x. And 2 to the power x is k. This is also k, so it becomes k squared. Plus 6k, and it was saying, let 2 to the power x be k. I can take 16 to the other side, minus 16, and now it is a trinomial. 1, 2, 3 expressions. It's a quadratic equation. Then I think I can factorize nicely. And again, you can use the quadratic formula. I'm not a huge fan of it, but it's doable. And then here I have the plus 8. Here, the minus 2. When you do the maths, that means k is 2. On the flip side, k is negative 8. But we are solving for x. And I said k previously is 2 to the power x. So we're good on this one. 2 to the power x is 2. Drop the powers. X becomes equal to 1. Then here, you've got 2 to the power x is equal to -8. I want to teach you something. This is a teachable moment. Follow me. It's impossible in maths that you put a power of x which will give you a negative number. It's impossible. Okay, let me prove it. If I put 2 to the power 3, I get an answer of +8. So it's a +3. If I put 2 to the power -3, I get an answer of 1/8. Try it in your calculator. It's 1/8. So mathematically, and you will learn this from the topic inequalities and equations, which I think some of you already started to do it or will do it. It's impossible for exponents to have a power which will end up, when you do the calculation, giving you a negative number. It's not possible. Whatever value for x you put here, whether positive or negative, your answers will remain positive. So mathematically speaking, we say this is not equal to -8. So you only have one solution here, which is basically when x is equal to 1. Right, I'm hoping people are seeing what I'm doing and are understanding. You let me know whether there's a struggle, fam. I want to try number 2. I'm going to do my last couple of questions here. Then we'll see how we will handle the third topic at a different time. All right. All right. Let's try number 2. Try number 2. Let me do number 2 together with you. I'm going to take this out. Gone, going. Number 2 says 3 to the power 2x plus 6, 3 to the power x minus 27 is equal to 0. And I think I see what I see. There's a 3 to the power x here. There's a 3 to the power 2x. So I'll say let k again be 3 to the power x. So that leaves me with k squared plus 6k minus 27 is 0. And then I think I can always do the factoring out nicely there. And then I think this should be plus 9 minus 3. So k is -9, or k is +3. 3 to the power x, that's my k. So x is 1. Then here 3 to the power x is -9. But I think I did explain on the previous question that it's not going to be possible. And then you've got only one solution here. I think I'm okay with that, right? Somebody says, why don't I make 27 the base of 27 to a base of 3? I can, but it's not going to help me out with anything, right? Because even if I do, I'll have it like this. 3 to the power x minus 3 to the power 3. Then what? There's nothing common between all of this. There's nothing. So I can't do much to it. So then eventually you would need to get into a trinomial version. All right, that's number 2. And just for interest's sake, I want you to try number 3, number 5, and we ended up with number 6. So let's try these ones. These will be our last questions, and we do that for the next 5 minutes or so. So let's try it. Let's see what's happening. Please let me know. All right, so you let me know if there's a struggle. I got your back. We are 3, 5, and 6. 2 more minutes, guys. 2 more minutes. All right, I think we should be good now. We should be. So it's 4 to the power of x plus 4 dot 2 to the power of x minus the 5 is 0. I could change 4 to a base of 2. So eventually, right, 2 to the power of 2x plus 4 dot 2 to the power of x minus 5, all that equates to 0. Then eventually this, then we say let k again be 2 to the power of 2x. So that's k squared plus 4k minus 5. I think we're pretty much seeing the wall picture here. And then here you've got that, and then you've got that. So I think that should be a plus 5 and a minus 1, if I'm not mistaken, there. So it's 2 to the power x, not 2x, to the power x. So I think it should be a plus 5 minus 1, if I'm not mistaken there. I think, yeah, there you are. So k is negative 5, which I say is not applicable. Then k is a positive 1. 2 to the power x is a 1. So then it becomes 2 to the power 0. So that they become the same base. So x becomes 0. This won't work. Do you guys get this? Talk to me. Yes or no? Yes or no? Just text me and text there. Yippee, yippee. That's lovely. Love it. Okay, let's try number 5. Number 5. Just in case you didn't get it, just make sure that you write it as you see it. You can take a screenshot of it. That's still okay. And then you can write and complete it later. Number 5, quickly. Number 5 says, and again, can I just go? Oh, okay, this one is more interesting. So it's 3 to the power 2x minus 2. I can change this 3 to the power x plus 2 into this. Yes, yes, I can. There you are. So that's what you have there. So you will then say to yourself, let k be 3 to the power x. So we will get our k squared minus, there's a 2 there. There's a k there. There's a 2. So the 2 and the 2, they give you a 4. And then the k, negative 4k, plus 81. If I'm not mistaken there, that should be, this should be 2 squared, actually. So that should be 4. 4 times, that's 8. Work with me there. I want to take this out. Oh, can I just take this out? Because I don't take this out. Okay, some people are still debating on the previous question. What happened? Let me see what the k. Someone says I wrote k plus 5k minus 1. And then you left it there. You must solve for k eventually. So I was saying to you guys, when you break this down, there's a 2, right, already. Then 3 to the power x, then 3 to the power of 2. There's 3 to the power of 2 there. So, or let me write it on the side. I need to, you've got this part. So it becomes 3 to the power of x dot 3 to the power of 2. So I'm hoping you understand that. All right, so this is 3. Yeah, my 3 is ugly. Excuse me for my handwriting. I really don't know how to write properly. Okay, so this is what you have. This is now let k be 3 to the power x. That becomes k squared minus, there's a 2, I think, times 3 squared, which is like 9 times 2. That should be 18 with the k there. So I think, yeah, that was where the issue was. And I think there should be a 9 and a 9 when you're factorizing here. Yep, it's a 9 and a 9. So it's negative 9, because that's 81. So basically k is 9. So 3 to the power x is 9. That means 3 to the power 2. Bases are now the same. Did you guys get x as 2? Did you? Yes or no? Okay, others are saying yes, others are saying no. So I think we're on the right tracks with some. I'm hoping that you're learning. I'm hoping that you're learning in all of this just to play around with all those things and then take it up from there. Right, then our last one is question number 6. You let me know when there's a problem. Our last one, then we'll have a bit of some chat, like 1 minute chat, just to get a feel of how you guys feel about the lesson. Then also what we're going to do next, blah, 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 blah. Okay. Okay, I'm taking this out. Gone, going. The number 6 says 3 to the power x to the power 2 over 5. Well, that's interesting. Minus 5 to the power x to the power 1 over 5. Then minus 2 is equal to 0. So I think the predicament is between those two, x to the power 2 over 5, x to the power 1 over 5. But look at how you can be clever. You know, you can write 2 over 5 like this. 1 over 5 to the power 2. You can write it like that if you want it. It's proper. Because x to the power 1 over 5 times 2 is actually 2 over 5. X to the power 1 over 5 times 2 is 2 over 5. Then you go and say, let k be x to the power 1 over 5. So now you are dealing with 3k squared. This is k minus 5k minus 2 is equal to 0. You can solve this quadratically. You can even use the quadratic formula. I'm not a fan of it, but let me show how you'd use it. I think you guys have done the quadratic formula already. So it's going to be K is equal to minus B. I'm hoping people have done this. Plus or minus root of B squared minus 4AC. All of this. You can even factorize it the normal way over 2A. Can do it whichever way you would put it across. Try it and tell me what numbers you get for K. Let me get you involved. What values do you get for K? Let me get you involved a bit. What values do you get for K? Talk to me. I said 2 and negative 1 over 3. So I get a 2 and a negative 1 over 3. So then it means x to the power 1 over 5 is 2. Now, this one is interesting because we don't know what the base is. We really don't know what the base is. All right? So then it's easy because now you can reciprocate power by the reciprocal. 1 over 5. And then here you power also with 5 over 1, which is like 5. So it's 2 to the power 5, which is 32. And then you come here again, x to the power 1 over 5 is negative 1 over 3. Don't mistake this. Don't mistake this. Please don't mistake this, where I said it's not possible. And then this. Don't mistake it, right? Or let's say 2 over 3. Don't mistake it, okay? Don't mistake that, please, because they're different, these things altogether, all right? So then at the end of the day, you guys, are you getting x is 2 and x is negative 1 over 3 or what? Because someone just sent a different answer here. Is it x is 2 and other one is negative 1 over 3? Is that what you get for your k values? Sorry, for your k values. Confirm with me. All right, someone is saying yes, say, yes, say. Just one confirmation. Or no, yes. I'm so confused. Let me do it myself. Right. Let me do it myself quickly. Others are saying yes, others are saying no, others are saying yes, others are saying no. What is the right answer there? Right. Yes, I get a 2 and I get a negative 1 over 3. Then when you're here, again, you do the same thing. You reciprocate negative 1 over 3 to the power of 5. Remember, it's 5 over 1, which is like to the power of 5. And I think when you say that, negative 1 over 3 to the power of 5, I'm not so sure what you get. Get involved, tell me what you get. Negative 1 over 3 to the power of 5. I get negative 143. Negative 1 over 243. Negative 1 over 243. And those are values for x at the end of the day. Right there. So again, I said, don't confuse this where we didn't know the exponent and this where you don't know the base. So this one won't work, definitely, but this one can work. That's why I end up with an answer like that. All right. Did you guys get this question? Anyone who got this? Anyone who says, yeah, boo, I got it. Because get this, yes or no, no or yes or no. Let me hear that. Yes, wow, lovely. Let me hear others. Yes, no, yes, no. No, it's fine. I guess we're all learning eventually at the end of the day. All right. So what I will do is, I think I did send something on our WhatsApp group, and those that are listening to me on YouTube, you can get into my WhatsApp group 073-974-8498. That's my number. Just send me a WhatsApp and tell me what grade you are, and I'll put you in the group, which is quite very interesting and useful. And it's going to get even better as we get towards the exams, where it's going to be quite a lot of activity. I'm going to be doing another free lesson for physical sciences for grade 11s on Thursday, this Thursday. And then I'm also going to do another free lesson for grade 12s on Wednesday, just in case you need any help from that perspective. All right, family members, I'm going to stop the recording now. Then we have a bit of a chit chat, and then we go our separate ways. Stop recording. So what I'll do, sorry, the surds, hey, Buffett, we'll try to do the surds. I'll make a plan for it as well. I think I bit more than I could chew. There's just so much to give to you guys, and I really love teaching you guys a wonderful class. So we'll catch each other on the next side.